All right, so we're going to be taking a look at Journal 32 now, and we're going to start off with some old problems that you might remember. So it's solving out for quadratics. And when you're solving for quadratics, you might want to refer back to the project where we solved it in 4 different ways. Let's go ahead and list those 4 ways for solving quadratics first. So there is the graphing that you had to do. So graphing. Give me one sec, let me switch to this pen. So there is graphing. There is factoring. So you can solve by factoring if you can factor. And then there's completing the square. And then there is the quadratic formula. The quadratic formula. Now, let me just say there's also one more method. It's called taking the square root. And this one is kind of more of a short method. Like if you're trying to, like for this one, for example, you would move the 4 over and then try to take the square root to get rid of a square. So I thought I'd add that in. So there's really 5, but we really don't announce this one as a type of method to use. It's just like how you solve when you have x squares. So when we're working out this one here, notice it's a trinomial. So when I see a problem like this, I try to attempt to factor, because that one I can try to figure out what numbers multiply to give me 8 but add to give me 6. So 2 numbers that multiply to give me 8 is 4 and 2. And 4 and 2 do add to give me 6. So I think this is factorable. And so x is maybe plus 4 and x plus 2. So if I do 4 times 2, I get positive 8. If I take 4 and I add it with 2, I get positive 6. So this works. And then once we get our 2 factors, you want to set each factor equal to the 0. So I'm going to set each factor equal to 0. And notice that when I do this, the x is really easy to solve. All I have to do is move over the 4 and the 2. So I'm going to subtract 4 over for this one. So x is equal to negative 4 for the first x value. And this one is equal to negative 2. And so remember, when we have quadratics or x squared, so if our highest power is 2, that means we should have 2 x values. And we did. So this one is also x squared, so we should be getting 2 x values. Now to solve this one, we actually can't use factoring here, because this is a plus sign. When you have a binomial or 2 terms and it's a plus sign, you can't factor. If it's a minus sign, you can. But this one, obviously, is a little bit easier just to try to get the x squared by itself first. So if you subtract x squared, or as you subtract the 4, my bad. If you subtract the 4, the x squared comes down, and then you have a negative 4 on this side, and this is where you want to take the square root of both sides. So the 2 and the root cancel. X comes down, the square root of negative 4. So let's just think about it for a moment. If you have a negative number, that means if you have a negative number under the root, you have an imaginary number. Now the square root of 4 is 2, and then you would have a plus or minus, because if you take a square root, you need a plus and minus. And so from there, we have our final answer. X equals positive 2i and negative 2i. So that actually counts for 2 x values. So here's the thing. We're going to actually be dealing with some quadratics when we're factoring cubes. So the most important thing that we'll need from the 4 methods that we've learned is quadratic formula is probably the most important, and actually taking the square root, it will come into being useful too. And then sometimes factoring can be helpful too. So basically these 3 are going to be the ones that you'll reflect back on. I don't recommend graphing because that's estimating your x values, so you're not going to get very accurate x values. And completing the square just is a little bit of a hassle, especially when you're dealing with more complicated quadratics. So I recommend quadratic formula. All right, let's take a look at today's slides. So let's talk about factoring when you have 4 terms, as you can see here. So if you have 4 terms, you want to use the method called grouping. Grouping works great when you have like more than 3 terms. So in this case, notice how your exponents are also in order from highest to lowest. So third, second, first, and then your constant. So you want to use grouping to factor. And in this case, when you group, you want to put 2 terms in each group or parentheses. So I'm going to group these two and then these last two. And so from there, you want to try to pull out your greatest common factor. So looking at the x cubed and the x squared, you can pull out the lowest power, which is x squared. And that means you leave behind two terms, since there were two terms here. So if you take out two of the x's from each one, that means you're only left with one x on the first one. And if you take two of the x's from this one, that's all of the x's. That means you have a -5 left over. Notice that when you redistribute, you'll get x cubed, and if you distribute the x squared to the 5, you'll get -5x squared. So what we're doing is factoring out as much as we can. This one has a minus sign, so let me bring down that minus. And then inside the parentheses, you have a 4 and a 20. Now, they're both divisible by 4, so I'm going to pull out a 4, since that's the most I can pull out. And then that leaves behind an x for this one. And then 20 divided by 4 gives me a 5. And so what I need to think about is what sign goes here. Notice if you pull out a -4, you have to redistribute it to check. So -4 times x gives you -4. -4 times 5 gives you -20. So in order to make a positive, we need to make sure that this is a negative. Notice that if I take -4 times -5, that makes a positive 20. So if you're pulling out a negative number, so if this middle term is a negative, then you need to make sure that this is the opposite sign. All right, so the right hand's still 0. Notice that when you factored, you have two x minus 5s. So you can take them both out and just have x minus 5 outside of the parentheses. And then you need to figure out what's left over. So in this first one here, all right, so from here, we're going to figure out what is left over in our two terms. So we have x minus 2. And in this one here, we have -4. So I'm going to put in a -4 here. And then this side is equal to 0. So what I'm going to do now is take each of these factors and set them equal to 0, just like how I did those quadratic formulas. I mean, not quadratic formulas, those quadratic equations. So I'm going to grab x minus 5, set it equal to 0, and x squared minus 4 equals 0 as well. And then I'm going to try to get the x by itself by adding 5 to both sides. I just need to isolate my x. And then this one here will be a +5, so x is equal to +5. And then this one, I need to move that 4 over, kind of like what we did in the belt work here. So I'm going to add 4 to both sides to cancel that out. X squared comes down, 0 plus 4 is 4. And then I got to take the square root of both sides. So the 2 and the root will cancel, giving you just an x. And then the square root of 4 is just 2. But we need a plus and minus because you took a square root, so you have a +2 and a -2. I want you guys to look and see what is the highest power in this equation. Notice the highest power is x equals x to the third power, right? So if this is the third power, that means you should have 3 x values. You have 1, and this counts as 2, positive and negative, so that's 2 x's. So that's a total of 3 x values, which is exactly what you want. So with 4 terms, you want to do grouping, and then once you get your factors, set them equal to 0, solve for your x. The next one here, I'm going to show you one that only has 2 terms. All right, so this one here in example 2, I have 2 terms, as you can see. And so this one, when you have 2 terms, you don't want to do grouping. You want instead to use the sum and difference formula. Now, because you have a plus sign, you need to use the top equation here. And in this case, I'm going to take the cube root of my first term and my second term, so I can figure out what my a and b is. So to do that, let me shrink this down just a bit. There we go. So I'm going to take the cube root of my x cubed and the cube root of 64. So the cube root of just x is, x cubed is just x, right? Because x to the third power gives you x cubed. Now, the cube root of 64 is actually 4, and how I got that was you could use the calculator. If you hit math on the calculator and you hit option 4, you'll be able to find the cube root button. Or just, play a little bit with the numbers. Like, if you take 4 and you multiply it, 3 times, so 4 times 4 times 4, it gives you 64. So you could just keep playing with the numbers until you figure out what number cubed would give you 64. Once you figure out this part, you have figured out what A and B is. And then this side's still 0. So what we can do is replace A to the third plus B to the third with its factors. So it's a binomial first and then a trinomial. So I'm going to create a binomial and then a trinomial. And then I got to put my signs in. So if this is a plus sign, I need a plus sign for the first one, then a negative, and then a positive. So I'm going to put that in. And then my A will go here. Notice how A is next. And then so is my B. So I need x plus 4. And then afterwards, it's A squared. So that's going to be x squared. And then A times B, which is x times 4, which is 4x. And then after that, it's going to be your B squared. So B here is 4. 4 squared is going to give me 16. So notice that now I have everything in factor form. I could just set it equal to 0. So I'm going to set the first factor, x plus 4, equal to 0. And then the other one, x squared minus 4x plus 16, equal to 0. So from here, all I need to do is basically solve for x with this one. But this one here, notice it is a trinomial, and I know it's so tempting to try to factor this, but I'm going to tell you right now, when you use the sum and difference, the sum and difference trinomial is not factorable. So don't waste your time trying to factor, because you will basically not find it, because it's not factorable, because it'll give you imaginary numbers. So what you have to do is you're going to have to use the quadratic formula for this trinomial. So you'll use the quadratic formula here. And that is your x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So if you just don't remember the quadratic formula, here it is. But we're going to solve out this one first, because this one's pretty easy. To get x by itself, I need to move this 4. So I have to subtract 4. So x is equal to negative 4, and that is one of my answers. Now this one here, I have to use the quadratic formula. So I need to figure out what my a, b, and c is. So a here is 1. B here is negative 4, and C here is 16. So remember, A is always the number in front of x squared, B is always the number in front of x to the first power, and C is the constant. And so from here, all you have to do is plug it into the formula. So let's go ahead and do that. So that's going to be negative 4 plus or minus the square root of B squared, so negative 4 squared minus 4AC, which is 1 times 16. And this is over 2 times my a, which is 1. So 2 negatives make a positive 4, plus or minus the square root. Negative 4 squared gives me 16. And then negative 4 times 1 times 16 gives me a 64. And so then bottom here is just 2 times 1, so that's just a 2. Need more space here, so I'm going to readjust. So with the root, I can subtract the number. 16 minus 64 gives me negative 48 over 2. And so when I look at this, I know that if this is a negative root, I need to make a I, or imaginary number. So I'm going to put an I next to this, and then a 2 in the bottom. But I also have to take the square root of 48, so I need to simplify here. So let's just think about how 48 breaks down. So 48 are factors of 4 and 12. 4 can be broken down as 2 and 2, and 12 can be broken down as 4 and 3, and 4 can be broken down as 2 and 2. So in this case, I have a pair of 2's and another pair of 2's. So these 2's will come out, but they need to multiply each other. So 2 times 2 gives you 4. But then you have a leftover 3, that's prime, so that will go back in the root. And so any leftovers goes back in the root, any pairs comes out, but you need to multiply it out together. So instead of 48 here, I can replace that with 4 plus and minus 4 square root of 3i over 2. And then one last thing is that notice that this is a 4 and that's a 2. So both of these are 4 and that's a 2. So you can reduce it or divide each one by 2. So if you divide this by 2, you get a 2. 2 divided by 2 is 1. So really, this can be written as x equals, because these are all x's, right? X equals 2 plus or minus 2 square root of 3i. And you could put this all over 1, but when you put something over 1, it's just itself. So this here is the other x value. So that counts as 1x, and because it's a plus and minus, that counts as the other 2. And that's it. All right, so we're going to look at the packet here next. So packet 7, page 2. So in this packet, this is problem number 2 on page 2. And notice this is in 4 terms. So if you notice something's in 4 terms, you got to group it. So using grouping, I'm going to group 2 of them together, and then the last 2 together. And so when you do this, you want to factor out as much as you can. So that's x cubed, and that's x squared. So the lowest power you can bring out is x squared. And so then I bring down the x, and so then we have plus, so the x comes down, and this is x squared. So you took away that x squared, so you just have a 6 left. And then this one here is a 4, and that's a negative 24. So 4 and 24 can have in common is a 4, so you can divide out a 4. So if I have this minus sign, I'm going to bring that down. I'm going to extract or factor out a 4. And so I have an x. 24 divided by 4 is 6. Now, notice again, this is a negative sign. So when I distribute, that needs to be a negative. So this needs to be a positive sign. Notice when I distribute this negative 4 to the 6, you'll get a negative 24. So this works out. So from here, I have x plus 6 and x plus 6. So those two factors are the same, so I can factor that out as x plus 6. And then what I have left over is x squared. And in this one, I have a minus 4. And this is all set equal to 0. So I'm going to do x plus 6 equals 0, and x squared minus 4 equals 0. And to solve this out, I need to subtract the 6, so that cancels. So x is equal to negative 6 for the first one. And then this one, I need to add 4 to both sides. So x equals positive 4. I take the square root of it to get rid of the square. So the root and the 2 cancels, so that gives me x equals 2. The square root of 4 is 2, but that would be plus or minus 2. And that is my other 2x value. So it's a positive 2 and a negative 2 and a negative 6 for my x value. Since this is x cubed, you should have 3 x values. And that's it. So if you notice 4 terms, got to group them, find your factors, set them equal to 0, solve for x. All right, so I'm going to do also number 4 with you. This one is the trickiest one. So to start this problem, notice it's only 2 terms. So you need to use the sum and difference. And so for the sum, because this is a plus sign, that's your a cubed plus b cubed equals binomial, trinomial. This is a positive, negative, positive. And so then this is a squared, a times b, and then that's your b squared after. So this is the formula if you're doing a binomial. So first you need to take the cube root of both terms. So in this case, the cube root of 8 is 2. The cube root of x cubed is just x. So now you found out what your a is. So basically I took the cube root of both of these and put them in here. The cube root of 27 is 3. because 3 to the third power is like 3 times 3 times 3, which is 27. And so from there, I figured out my A, I have my B, so I'm going to literally plug this into the formula. So first off, instead of writing it this way, or the two terms, you can write it with those factors. So you have a binomial and a trinomial. And so in this case, you have your plus sign first, then your negative, then your plus sign. I'm literally just following the formula here. Your A will go in this spot, and so that's going to be 2x. And then your B will go in this spot, so that's going to be 3. And then after that is your A squared. So A squared is taking the 2x and squaring it. So you square the 2, you get a 4. You square the x, you get an x squared. So make sure you square everything, even the 2. Then the next part is A times B. That will go in the middle. So 2x times 3 gives you 6x. And then last but not least, your B squared is going to be taking this 3 and squaring it. So that gives you 9. And then from there, you want to take each of your factor. So if you have this factor and this factor, you want to set them equal to 0. So this one here is pretty simple because you just have to get this x by itself. So I might like subtract over the 3. So that cancels. So I have 2x equals negative 3. If I divide by 2, that cancels. So x is equal to negative 3 over 2. And so x is equal to negative 3 over 2. This one here, I'm going to be using the quadratic. So remember I said that this here, when you use the sum and difference, this is not factorable. So you want to use the quadratic formula here. So if you want to pull up your notes and figure out what's the quadratic formula, it's just your x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So using this formula, I'm going to figure out what my a, b, and c is. So that's going to be 4, negative 6, and 9. So x equals, looks like negative 6, since that's negative b first, plus or minus the square root of b squared, so that's negative 6 squared, minus 4ac, so that's 4 times 9, all over 2 times my a, which is 4. And then I want to simplify this down. So that's positive 6 plus and minus. Negative 6 squared is 36. 4 times 9 gives me 144. 2 times 4 on the bottom is an 8. And then from here, let's try to simplify this root. So 36 minus 144 gives you 108 negative over 8. And so I have a negative sign under the root, so I know this is the square root of 108i, because it's imaginary. From here, I might want to attempt to try to simplify this root, 108. So 108 breaks down into some factors. Try 36 and 3. So 36 can be broken down as 6 and 6. Because I immediately notice that this is a pair, right? I can call this a 6 to be outside. And I don't have to break down these 6. I could, but I will notice that I'll just get a 6 outside in the end. And then the leftover here is the 3. So 3 goes back inside. So this is really 6 square root of 3i over 8. And what I notice is that basically this 6 and 8 can all be divisible by 2. So if I divide everything by 2, this by 2, this by 2, this by 2, which is, sorry, if I divide that by 2, that makes a 3. So that should be a 3. My bad. If I divide the 8 by 2, I get a 4. So I can really write this as 3 plus and minus 3 square root of 3i over 4. And that is what x equals. So my x can equal this, or it can equal negative 3 over 2. And there we have our x values. So I hope that helps you out with your homework. So anytime you notice a binomial, you want to use the sum or difference formula.